So, hello, welcome to the Frameworkshop. I'm Evan. Literally everyone here already knows me. So, right. So, I'm just going to be here to talk about game frameworks, like what they are, how they differ from game engines, and um, why you would use them, etc. So, getting started. So, what is a video game? It's a program, it's real-time software. And so it has certain requirements that are different from if you were writing like a web application or something, like it wouldn't need to be responsive in like the same way that a video game is. Video games need to communicate with specialized hardware and peripherals. So things like a graphics device and a monitor and a video game controller, like audio input and output, etc. Yeah, they need to read input devices like controllers. They need to be able to display images on screen very rapidly. We're usually talking minimum 30 frames per second, which gives you about 30 milliseconds, give or take, to display a frame. And if you want 60, even less time. If you want 144 hertz, you have even less time. And they play sounds. So these are all fairly complex communication tasks where your software has to be interfacing with a lot of different hardware. So, if you really wanted, you could code all of that stuff completely yourself. I don't think anybody does that anymore. And they usually go with some kind of a program to help them out with those tasks. And so you have game engines and you have frameworks. So what's the difference? These terms are not really very well defined. It's kind of like, I think people kind of just pick the term based on vibe. There are some differences. I would think of an engine as like a far more monolithic program than a framework. So the engine is going to control your whole program flow, and it's usually going to like export some kind of executable for you. It'll have like a built-in tool set, like different like GUI editors. Like they'll usually have like a little export button for you that will like build the program. Engines are usually very opinionated about assets and behavior formats. So like in Unity, like every game object you code is going to be like a mono behavior, and in Unreal they're all going to be like actors or things like that. And the asset formats, like when you bring assets into Unity, it's going to like process them into certain specific formats with like an asset pipeline, etc. And engines are usually proprietary software, meaning that the rights for the software are controlled by a private entity. There are some exceptions. idTech 4 is open source. Godot is open source. So yeah, there's a few engines that are not proprietary, but the really widely used ones like Unreal and Unity are proprietary. So a framework, by comparison, so a framework's also going to control your program flow to an extent, but they're a lot more open-ended. A framework will usually encourage you to build your own editor or asset tools, or like use ones that other people have built for that framework. Frameworks will have widely varying levels of like batteries included features, by which I mean that some frameworks are going to have like a lot of structures to they'll be more opinionated, and like they'll give you kind of like overarching structures to like build your game with. Other frameworks will be very bare bones and kind of just give you like basic utilities for interfacing with certain systems. And frameworks are almost always free software. I can't really think of any exceptions right now. Usually, if you're going to do something proprietary, you're going to want it to be a sort of like more monolithic package that can do everything for you. And frameworks tend to be a lot more, like they tend to focus much more on like lower level tasks. So a note about software licensing. So a proprietary license grants you no real rights. The terms of those agreements can change whenever the company that owns the proprietary license wants to. I mean, we just saw that with Unity. Yeah, Unity just pulled the rug out from everybody. And there's not really anything you can do about it except to like complain on Twitter or whatever, for all the good that does. Yeah, John Riccitiello did just get fired. They'll probably replace him with someone equally bad. So yeah, that's one of the big disadvantages of building a game with a proprietary license is that those terms and conditions can change out of your control. Like a lot of things are out of your control in a system like that. You're depending on the company to care enough to fix bugs that you find, or like fix workflow issues, and you usually cannot look at the source. There are some exceptions to that, like Unreal lets you look at the source, even though like you can't modify the source and redistribute it or anything like that. You can look at and make changes to the source code on your own project. So by contrast, a permissive license would be something like an MIT license or a BSD license, zlib license. Those licenses grant almost no restrictions to using the source code. You can inspect and modify them and redistribute them as you please. Usually the only restriction on that is that you have to credit somebody if you modify their source code. And my encouragement for releasing your code permissively is that it encourages collaboration. I know that I'm going to talk about this later, but I've worked on several open source projects, and the nice thing about it is that if it becomes widely used enough, you usually end up in a position where people are fixing things for you because they just can, and it's good for their workflow. And when some person fixes something, it gets fixed for everybody. And I think that's like a really nice way to work. Releasing your code permissively also frees you of responsibility. I think this is something a lot of people ask me because I've worked on some open source frameworks, and they're like, oh, why don't you sell it? And I'm like, well, then I have paying customers, and they're writing me angry emails when something is broken, and I have to be responsible for that forever, or just end up letting people down. The nice thing about releasing your code permissively is that if I decided that I don't want to work on FNA starting tomorrow, I don't have to. It's gonna keep going. There'll be other people there to keep using it and working on it, and I can just kind of walk away. The disadvantage being that you can't really control who uses your software or how they use it. You have to be comfortable with that. If somebody uses your project to make something that's wildly successful, they don't have to kick you anything back or anything like that. And I think that's just part of the deal. And it doesn't really bother me that much because I think that building developer communities is more important to me than becoming personally enriched off of building tools. So here's the basic anatomy of a framework. Not every framework is going to totally respect this model, but I think the overwhelming majority of them do. So usually have a core layer, and the core layer is something that is written in a systems language like C. It's more low level. And those are going to be the components that are responsible for directly interfacing with the operating system and the hardware. Elements that require high performance, like a lot of communication, specific memory management requirements, those kinds of things are going to go in the core layer. Now, there are some frameworks Raylib is the one that comes to mind. It's written completely in C, and you can interface with it directly in C. Some people like that. But usually there's some kind of scripting layer on top of the core layer, and that's going to be in something like a managed language. And managed languages are they come with their own runtimes. They usually compile to a virtual machine or something. So those would be languages like Lua or C#. And those layers intend to prioritize the ease of writing code over raw performance. So if you want absolute maximum performance on everything, you would just write everything in C or C++. It's going to be way faster than anything that a managed language can give you. However, sometimes the trade-off of something that does a little bit more for you is worth the decrease in performance. our game that we're working on right now, Samurai Gun 2, is, it's using C# for the scripting layer, and I mean, it still gets like 500 frames per second on like my machine that I built like 10 years ago. So I think it's fine. So the framework will usually provide structures within the scripting layer. We call that the API, or the application programming interface. And that's going to be how your game primarily interfaces with the framework. And scripting layer calls into the core layer via something called a foreign function interface. And this is basically a way that native programming languages like C let other programming languages call their functionality directly. And like, you don't need to really understand how it works. Just know that like you can write a library in C and then provide like a specification for it, and then other languages will be able to call into it arbitrarily, and it'll run those functions. You don't have to write all of your program in C. You can just call into C functions. That's how most frameworks work. So a note about memory management. C, if you're writing in C, you're going to use the malloc and free functions to manually allocate long-term memory. And the main disadvantage of that is like if you're working with a less experienced programmer, or people who don't really program at all, I think managing memory manually can be kind of a big task. There's a lot of pitfalls. And you have to be really disciplined when you're writing code to avoid memory leaks and null references and crashes and like all kinds of stuff. So the nice thing about managed languages like Lua or C# is that they automatically manage memory. And I put scare quotes around that because you think like especially when these kinds of languages were getting really popular in like the early 2000s, everybody thought, oh, the garbage collection will fix everything. You're never going to have to think about managing memory ever again. You can just write whatever you want, and the runtime will clean it up for you. That is definitely not true when you're making games. Again, games are very high performance applications. So you don't have any control over garbage collection. So if you're leaking object references like crazy, you're going to have big problems with your frame rate. It's going to be very unstable because garbage collection will sometimes have to stop the entire world to clean up references. And, when you see people be like, why is my Unity game stuttering every 2 seconds? It's because of garbage collection. And like that's true of like any C# program. It can happen in Lua as well. So what's that? Not that, yeah, it can. Yeah. There are patterns for avoiding garbage collection. You can do object pooling, which is where every time you need a reference to like a long-term object, you can grab it from a pool, and then the pool is responsible for managing the references long-term so they don't get garbage collected. You can just simply avoid allocating new objects when possible. Like C# in particular gives you some tools for avoiding allocating long-term memory in specific functions. You can use libraries that manage like zero garbage allocations for you. Like I know a lot of game framework tools have APIs that will avoid generating long-term memory for you. So you just have to be aware of that stuff. So when I say, again, like automatically manage memory, like yes, if you're leaking references, the garbage collector will clean them up for you, but it comes at a cost. And ironically, when I write C# code, I often find myself thinking about memory management way more than when I'm writing C code because of all of the abstractions that you have to deal with. So something to consider. So what functionality does the framework provide? So usually you'll have some kind of operating system interaction layer. So like, creating a new window in the operating system context, opening a graphics context that can present to that window, initializing like an audio subsystem. Those things are not trivial to do yourself. And so the framework will do it for you. The framework usually has some kind of frame pacing mechanism. Some frameworks just do like, they'll just render as many frames as they can, and there's not really any kind of limiting. Some frameworks will separate like update and render functions, so you can have like an update loop that happens at a fixed time step, and then the render loop can happen on a different time step. It just depends on the framework. That stuff can be very nuanced, and the preference that I've settled on is to have like a fixed update time step and then some kind of like limited render loop that can be variably limited depending on like the refresh rate that somebody wants or something. But again, that stuff can get very nuanced, and it's nice to have the framework handle it for you. Input handling, there are a lot of different kinds of controllers out there, and like people will get really mad if your game doesn't work with their like DualShock 4 that they bought in like 2010 or something. So it's nice to be able to handle all of that stuff. So somebody might want to play your game with like a Sidewinder flight stick or whatever. So a Mad Catz controller or like some, $5 Amazon thing that they bought from China. Like, there's a lot of stuff out there. It's nice to have a framework handle all those. So usually the framework will provide some kind of input abstraction layer that will just generalize everything to like making queries on like a controller system, basically. Rendering, also an incredibly wide topic, but the gist of it is that there are many different rendering APIs out there right now. The fragmentation is crazy. You have DirectX 11, DirectX 12, OpenGL, Vulkan, whatever the hell PlayStation is doing, whatever the hell. We can talk about that. I like Vulkan, but a lot of people don't, and I understand why. The nice thing about framework handling rendering for you is that usually it'll provide a higher level interface for rendering, and then it will translate those render calls into specific APIs. So you write code once, and then your game can run using like a Direct3D 11 renderer or Vulkan renderer or whatever you need it to do. It's nice to have that handled for you because it can get very crazy. Audio, so like usually you'll have some kind of functionality for playing back sounds. That can get pretty nuanced, and frameworks will have different mechanisms for handling that. But it's not something that's fun to do at a low level, so it's nice to have the framework handle it for you. Math utilities, we all need math when we're making games. There's a lot of linear algebra, and you could write all that stuff by hand if you really wanted to. I don't. So it's nice to have the program handle matrix transformations for you and things like that. So why would you use a framework instead of a game engine? So I've already mentioned a few things, but I think the huge thing for me is just being able to control my workflow. Engines are very opinionated about how they want you to work in them, and they don't really like it when you go outside of those boundaries. And what I really like is that with a lot of frameworks, if you don't like how the framework does something, you can get around it pretty easily, usually. Build your own structures. Because they encourage you to develop things on top of the framework, you have a lot of control over how everything is structured. If your artist likes to work a certain way, it's very easy for you to build structures to accommodate things like that. If your designers like to work a certain way, you can accommodate that. You end up bending the framework to your will instead of what you end up doing with more opinionated engines, which is that you have to work the way that it wants you to work. Independence, so I was talking about this with like software licenses. If you made your game in a proprietary engine, who knows if that's going to be supported or viable 10 years from now, what the licensing changes will be, if the API will be the same. Bo and I worked on Hyperlight Drifter, and, that's on like a long unsupported version of GameMaker. And there are things that theoretically we would like to be able to do to modernize the game and make it work better on more modern platforms, but it'd be very hard to do because it was built in an old version of GameMaker. We'd have to do a lot of work to bring that into the future, and like all of the licensing issues and stuff. So the nice thing about being more independent and depending mostly on free products is that those don't change over time. So if you build your game now in some free system, 10 years from now, when there's a PlayStation 6 or whatever, there's a good chance you'll be able to like get that to work without, a huge amount of effort. So just having long-term control is really nice. And that brings me to my next point, which is like controlling your IP. Like you have a lot more independence and control with a framework than you do when you're relying on something like Unity. And finally, you get the opportunity to, if you want, you can learn how stuff works at a much more fundamental level. One of the saddest things to me, as somebody who worked in GameMaker for a long time, is like, I was a programmer before I ever worked in Game Maker. So I knew how stuff worked outside of that framework, and a lot of people end up using Game Maker, but if you took Game Maker away from them, they would have no idea how to use a computer. And that's kind of sad to me. I think that part of the freedom of this kind of stuff is just knowing that you're not completely dependent on a very specific tool and a very specific workflow to do things, knowing that if that was taken away from you, you'd still have the capability to make a video game. I think it's really important to not be locked into a very specific way of making things. And part of that means just understanding like a little bit more about like how a computer works. So a note about SDL2. So I mentioned that most frameworks have some kind of core layer in C, and almost always that's going to be through SDL2. It is an industry standard library. Literally everything uses it. I think almost every game engine uses it now. It's incredibly useful. It provides a streamlined API access to OS and hardware features, so it doesn't matter if you're on Windows or Linux or OS X or Nintendo or Xbox or whatever. There's an SDL build that streamlines all of those calls so that they can be the same. It's written in C, supports basically every platform you can think of. It's free and open source. Everyone uses it. It's incredibly useful, and it's a great thing to know how to use. Now, if you're using a framework directly, you don't ever have to know what SDL is doing because the framework will probably be handling how SDL is called. But if you really want to know, how is SDL opening an audio context on Windows, like you can just look at the code and then you can learn about it, which is really cool. So the first framework I'm going to talk about is Love. So Love, it has a core layer written in C++ and a scripting layer in Lua. It's got an extremely simple API. I'll show you an example in a second here. It can build to Windows, OS X, iOS, Linux, Android. Several commercial games have shipped with it. I think it's a really nice little tool, especially if you're not such an advanced programmer. I think Lua is very easy to learn. It's very simple. It makes very simple assumptions. I have problems with Lua, like as a more advanced programmer, but I think as like a beginner language, there's a lot of things that are really nice about it. So like here's an example of like doing stuff in Lua, or sorry, in Love. It's insanely simple. Like loading a sprite is as simple as calling love.graphics.newImage and giving it a PNG. Drawing it is as simple as calling a draw function and a location. You can load audio from a source and playback very easily, just 2 lines of code. I think like the appeal of something this simple is like very obvious to me. Like you could have something drawing on the screen in like 2 lines of code. So that's the power of Love, and I'm going to be showing off how you can use that. Then we have FNA. So I'm a co-maintainer of this project. It has a core layer in C, scripting layer in .NET C#. It is an exact re-implementation of the Microsoft XNA 4.0 framework, which was very popular for indie developers in like the late 2000s, early 2010s. It was deprecated by Microsoft in 2012, but several developers, including Ethan Lee, who's now the primary maintainer, worked on creating a free re-implementation of it. So if you made an XNA game, 15 years ago, and you want it to run on a modern computer, you can do that with FNA, and everything should just work. So it is primarily a preservation project. It's interested in exactly recreating XNA, but people are also using it to build newer titles. It's cross-platform. You can build to Windows, OS X, Linux, iOS, Nintendo, Xbox, maybe PlayStation in the future. We're working on it. Hundreds of titles have shipped with FNA. Because XNA was so popular, people wanted to keep using it. So people have brought XNA games to other modern platforms using FNA, and they've also made new games with FNA. I think the big games that use it that you've probably heard of are like Terraria, Celeste, Towerfall, games like that. And then we have Moonworks. I wrote Moonworks. It's very similar to FNA, core layer in C, scripting layer in .NET C Sharp. I think of it as a modernization of XNA. I used XNA for a long time and FNA for a long time, and I ended up disliking how parts of it were structured and just rewriting huge components of it that ended up becoming like a unique framework. It builds to everything that FNA supports. We're using it to make Samurai Gun 2 right now. We got a small community of people who are using it, and it's being actively developed by me right now. There are lots of other popular frameworks that people use. Raylib is a big one. People really like it. It's written completely in C, so it's very easy to bind it to like any language that you want to use that's not C. Heaps is made in Hacks, which is like really popular with people who were used to the Flash way of working. So like the whole Hacks ecosystem evolved out of like ActionScript being like killed basically. And there's a lot of things that are neat about Hacks. And notably, Heaps was used to make Dead Cells, I think, which was a huge game. And then there's like a Rust developer ecosystem that's gaining popularity. I don't really know that much about Rust. There's a framework that people talk about a lot called Bevy. I've never used it, but if you like Rust, you'll probably like it. There are so many different frameworks out there. One of the nice things about frameworks is how easy it is to make your own. And so there's been like a huge proliferation, especially as game engines have become bigger and bigger and more locked down. I think there's pressure being exerted for people to make more of their own tools. You could even make your own framework. I did. It wasn't that hard. The choice of framework often comes down to your preference of programming language. So like if you really like Lua, like Love is right there. If you really like C Sharp, you've got like FNA, and like there's several other C Sharp frameworks. So a lot of it is just going to come down to like what you feel comfortable working with and like what your development workflow is like. So any questions before we get started on hands-on stuff? Yeah. Okay, yeah. Yes. Right. Hmm. Yeah. Right. Yeah. So many people are using a Deer ImGUI. It was called ImGUI until like a few years ago. They renamed it because it's just a term. It's just a generic term for an immediate mode GUI. And so the idea of an immediate mode GUI is that uh, every frame the GUI is like being recreated by calls to the GUI library. And that sounds complicated. It's insanely simple because you don't have to worry about maintaining like long-term state objects, which is one of the really hard things about doing UI. So I recommend the hell out of Deer ImGUI. It's written in C++. Some people have written like C bindings for it, and so you can hook it into like any higher level language. I use it for everything. It's the thing about Dear ImGUI is it's not great for user-facing UI. So like when you ship your game, I don't think anybody would use Dear ImGUI. It has like a very programmery interface. It's not like that. It looks fine. It's not like pretty or anything. I wouldn't use it to build like gameplay UI. But for development tools, you can get something up and running so fast. And like we're using it for a ton of stuff. I wouldn't recommend anything else, honestly. So yeah, one of the big limitations for people going from an engine to a framework is like, what does my tooling look like? And like, how do I build the game? And the reality is that you're going to be making a lot of those choices for yourself. You're probably going to be like building your own tooling for stuff like level editors or like, things like that. And that might sound like a big burden. I think that this is something that you almost always end up doing anyway, like on top of an engine. Like when we were doing Game Maker, like we didn't even use their level editor system. Like we just built our own like in the game anyway. So I think a lot of what I always tell people is that a lot of building a game is building the tools to build your game, and I think that's true whether you use a framework or an engine. I think the idea that the engine just gives you all of that stuff out of the box and can do magically everything that you always want it to do is not really true. All right, so we're just gonna get started. If you want, go ahead and like follow that link. I'll post it in the Discord, but you can go ahead and follow that link for the getting started guide for Love. And some example tasks I would give you: clearing the screen to your favorite color, loading and displaying a sprite, loading and playing a sound effect, moving the sprite around based on input, playing a sound based on input, and then anything your little heart desires that you want to do. If you feel like you've gotten a handle on Love and you want to try something else, you can check out the FNA template that I have posted there, and the FNA wiki should get you started. And if you're done messing with FNA, you can give Moonworks a try, and I'll just be floating around here. If you have questions, stuck on something, you want to know how something works, I can answer your questions. And yeah, just try some stuff out and let's have some fun. That's it.